Vishwas, would you like to start?
Thank you, Karina, and thank you for the great presentation. So my name is Vishwas Lele, and I'm CTO for a company called Applied Information Sciences. I'm also an Azure MVP, which means I've had an opportunity to work with our customers to architect different solutions using Azure, including Azure IoT solutions, and the recent announcement that we talked about today make it even more interesting in terms of building these enriched solutions. I'm sure we'll get into that, Karina.
Great. Jim?
Hey, good evening, everybody. Yes, as Karina said, my name's Jim Chastain. I am a program manager working on edge devices in Microsoft, but also I am a recently retired military officer. 6 months ago, I was in the Joint Special Operations Command as the Deputy Chief Technology Officer under Snehal and Tani. So I kind of bring a lot of things from Microsoft, as well as just some of my experience of deploying over the last couple of years as a military officer.
Great. So let's, we heard a lot about IoT and Edge, and it's interesting that we do couple the two. How would you, Jim, define IoT and Edge, or do you put them together, you separate them? What's your definition?
Yeah, I think they're definitely separate, but I would say they both have the common theme of you're trying to make better decisions faster, and you're trying to use that data where you're collecting it for better decisions. So, I think in the military, we kind of call it actionable data. And a lot of times where you analyze the data and the decision makers and where you collect the data are three different locations. So when you can kind of combine that all into one, you get really actionable data, and it really speeds up your operations.
Vishwas, what do you think?
Yeah, so I'll just take a step back. So Karina, I think everybody knows IoT, but it's probably for the sake of completeness, set of interrelated devices. Could be computing devices, could be mechanical devices, could be objects, and could be animals. I don't know if people remember, there's a very fascinating case study a few years back about connected cows for improving the production of milk. So it could be any devices. It could be human beings. I've heard Air Force talk about soldier as a sensor. So it could be anything. These interrelated network of computing devices is what we call the Internet of Things, essentially. So as these devices have grown, and if you look at Gartner, Karina, for example, today in 2020, according to Gartner, we have about 5.8 billion devices, which is an increase of about 20% and expected to continue to grow. So as you continue to increase these devices, as you increase the amount of data that you're collecting, it becomes important to try to analyze the data closer to the source, because there's a lot of noise in that data. And also, you want to be able to take more real-time decisions. So if you combine these two together, so IoT, interrelated network of devices, essentially, and edges, making the decision-making closer to these devices, if you will. That's how I separate the two out.
Great. Can you tell us a little bit about, what are you seeing in government? What are the hottest kind of technologies being used? We talked a lot about them this morning, but what are those big trends that we're seeing? How are agencies adopting IoT and Edge? So Jim, I don't know if you want to take that.
Yeah, I'll give my thoughts and turn over to Vishwas for his. I think one of the biggest challenges is what Army Futures Command is calling the DDIL, which is like the denied, disconnected, intermittent, and latent environments. And I go back to some of my deployments, especially early on as a young officer, where the technology crux was really your bandwidth. And I don't think that's the case anymore, because essentially, the edge devices now start really allowing you to sort out which data you really want to pass up, and which one you can analyze today. Because there's a lot of, I think as a lot of senior officers have talked about in the military, is they call it the big data problem. And I think that edge processing is key to funneling down big data into manageable sites to actually turn it into actionable intelligence.
Jim, are you seeing that adoption broadly in the DoD?
It's coming in pockets. I think there's very good use cases that have taken off. And I know that Army Futures Command standing up has been, and I speak a lot about the Army because, that's where I came from, but even all the services have started adopting similar things, where they're more willing to do a lot more experiments and pilots. So the answer is we're still in the infancy, but it is starting to take off.
Vishwas, can you tell us a little bit about just the workforce, perhaps, because I know you're doing a lot of consulting work around edge and IoT. If somebody's getting into this or interested in it, how do they engage, and where can they engage?
Yeah, so that's a great question. I think what has happened in the last 2-3 years is that the bar of entry for starting to build these IoT solutions has been greatly lowered. And here is why. First of all, if you think about the IoT solutions that people put together, there are some core elements of those IoT solutions. For example, we talked about Azure Sphere as part of the Q&A earlier. How do you talk to these devices? What kind of APIs are available, what languages are available. There's a wide choice around there. And then how do you get the data ingested, collected in the edge, and then how do you get the data ingested in some sort of a platform service or a cloud? How do you ingest that? What are the hyperscale services that are available that allow you to ingest the data, maybe stream your data, and then maybe analyze that data, and then be able to then make decisions out of that data? Those are sort of at a very high level, the building blocks of an IoT solution. So the way I would get started is, of course, you need to understand, what kind of sensors and what technology makes sense for you, and what infrastructure already exists. You have to start there, of course, but then you have to then look at, what kind of gateway devices you can use, what APIs are available, how can you ingest this data, can you make these decisions? So the best way to do this is, if you are coming in from let's say a data background, you will be able to architect a solution like this, especially on the ingestion side or the data analytics side. If you have a background in, let's say, real-time operating system, maybe you can play in the device or a sensor side. And of course, you have an analytics background, then you can essentially play in the Azure machine learning or data analytics space. The last thing I would say, Karina, is previously, if you had to build a platform like that, you had to do a lot of custom coding, right? You had to write a backend which got this data and then analyze this data. And now we're beginning to see a SaaS-like solutions. So you look at things like IoT Central, right? It gives you a complete way to manage without having to write any code. You define your sensors, you define a custom UI. So very little programming, you can have essentially the IoT backend up and running. So that's what's making a cloud developer. You may not have worked on IoT, but now you can play in that space and add value quite quickly.
So if, let's say, you're entering this space, what are some of the top challenges or lessons learned in implementing these technologies? Jim, any thoughts on that?
Yeah, and in full honesty, I was part of a digital transformation that literally went up in flames in a matter of days after working on it for months. And it all really comes down to, it's not an IT problem, it is a business problem. And there's a lot of things you can do, but the key thing for the government is to break it down into extremely small chunks and start there. And I would even say a lot of people focus on those really, really high impact areas, and eventually they want to get there. And I would just kind of give the advice to say, pick something that's fairly easy, that has a good value prop. And I'll give you one example that we did in my former jobs is maintenance. A lot of the government is fixated on, hey, we're going to do services at this time. We're going to change the brake pads at a certain time. But with some edge devices, some cameras, you can easily transform to say, hey, how much is that brake pad actually worn, and do I need to replace it? So those, it's a culture problem. Because for years we've said, hey, we're going to change those brake pads after so many miles. And then now to say, hey, I know it's past those miles, but that brake pad actually isn't that worn down. But those maintenance issues are a lot easier to kind of tackle. And it allows you to kind of learn and progress into IoT and edge solutions.
So Vishwas, I think I know anyone who's been in IoT, they'll talk about the security challenges. What do you see as kind of like those top challenges in IoT and edge, whether security or beyond security?
So I think you've called out the most important one. As soon as you have devices out there in the wild, the number of attack vectors just go up. How do you secure not just the sensors, but how do you secure the edge devices? And I would like to, post a link, and maybe we'll do that later after this session. There's a very interesting paper that Microsoft Research wrote about the 7 key characteristics of how to secure an IoT or an edge device. And things that were included, and probably many of the listeners today are familiar with the recent attack, which was on IoT devices. There's these hardware manufacturers which had user ID and password and hard-coded, and no easy way to change that. And all of these devices were then commandeered to launch a denial of service attack, right? So that's a common problem. So the Microsoft research paper had 7 characteristics of what you need to do to secure your device. Things like you cannot just be having a simple user ID and password that's same for every instance of the device. You need to have some sort of a certificate-based mechanism. You need to be able to have defense in depth. So even if the edge device gets compromised, the underlying kernel is still protected, and things like that. They put out, and I'll put a link out there later on tonight that you should look at. So that's a number one challenge. And then a lot is being done by the strategies that I talked about. In fact, if you look at Azure Sphere, as an example, it exhibits all of the 7 characteristics that the research paper talks about. All of the 7 things are there. So that's one common challenge. The other challenge, of course, is the data latency issue. Somebody said, and I can't remember the source, somebody said that in the next couple of years, the data generated outside the data center will be more than half of the data that CIOs will have to deal with, which means these data that's being generated in sensors is going to be coming into the data centers. So how do you make sure that you are bringing in the right kind of data, you're dealing with the latency, you're making decisions at the right point? So security, data latency, a couple of the challenges. And the third challenge, if I may, if I'm still within the time limit, Karina.
Yes.
The third, thank you. The third challenge, if I may, is what we are seeing is in the last 5 or 10 years, IoT has been about, you have these devices which get connected and they're sending some data over, and then you're analyzing the data. And whether it is, as Jim mentioned, you are tracking maybe some part in an airplane or some military logistics equipment, right? But that's an individual sensor being tracked. Going forward, the real value will come from when you can deal with these IoT devices in an environment. So you're not just dealing with an individual sensor. So let's say you're a manufacturing plant. You're not just dealing with individual sensors that are on the machines, but you may also be connected to maybe your supplier network, right? So we start thinking of those, but the challenges are, how do you talk to the other IoT systems? Maybe you're a manufacturing unit and you're talking to a smart grid. Maybe you are hosted in a smart city. How do you talk to these? What is the interoperability story? Because the true value of IoT will come when these things can talk to each other. And that's something that the industry is working on. So those are the common challenges, Karina, that I've seen.
Yeah, there's a lot of things popping up in my head, like, who owns the data? How do you secure the data coming in and whatnot? Which is interesting. So we have a question coming in for Jim right now, is when we're talking about making, data actionable and pushing that kind of, the reason we have Edge is to have real-time decision making where the data is created, is what we're hearing. So do you see a trend in pushing command decision or making the ability down to make those decisions at the lower level in order to capitalize on the influx of actionable data? So, what does that look like in DoD?
Yeah, that's a very, very good question. And the answer is absolutely. I think all the services are seeing that. And let me just give you one example is, one that the Marines are calling it the strategic corporal. I kind of call it the barbell effect, where kind of IT has pushed people to kind of push a lot of data into the hyperscale cloud. And then on the other side of the barbell is your data is being collected and analyzed near real time or real time where it's collected. So you don't, what we've traditionally done, and this is exactly the model that we used when I first started deploying, is you would have these centralized, regional data centers, and you still have some of them, but they're pushing out to the ends, hyperscale cloud one way and edge the other way. And that's allowing really two, I'd say, things. One is decisions closer to the edge, traditionally by people of lower rank that may have not necessarily made those decisions before, but then also collecting that data and using multi-source intelligence in the hyperscale cloud. Hopefully that kind of sums it up, but the answer is a resounding yes.
So often when we're talking about tech implementation or tech adoption, it's all about culture and workforce adoption. So Jim, kind of continuing on in that kind of thought, we're hearing that the DoD has an appetite to push that decision making down. Can you explain a little bit of what's happening in the culture and how the adoption, how are you seeing the adoption going as it comes to actually implementing the tech?
Yeah, and maybe I'll answer this in a couple different
ways. Or using the tech is what I should say, not implementing. The usage is always the tough part.
And maybe I can back up and say, as an IT professional in the military, I commanded 5 different organizations, mostly in special operations, and I go back and I think about all the decisions or the key decisions I made, and I felt like they were really gut decisions, not necessarily a data-driven decision. And just like me kind of growing up in this tech revolution that we've got going on, you're seeing that with a lot of the senior leaders. So they're getting extremely smart, even the non-IT folks. So the senior leaders in the government, they understand, and they're really pushing the limits of what the IT professionals can and should be doing. But it is absolutely a cultural issue, and it goes in all facets, like Vishwas was talking about the training piece of it. I mean, we're just now kind of catching up with trying not to run an IaaS platform in the government and trying to kind of shift that over to people who could do it better, and then using those uniform services. And I think it'd be the same for any of the other government agencies, to use those uniformed IT professionals to really do deep domain expertise at the edge. So, but without an end-to-end, understanding that it goes from the business to operations to IT, and they all have to be in line, is absolutely critical to any advancement in technology.
No, I mean, that makes me think personally, I don't think I'd pick a new restaurant without checking out Yelp and what my fellow folks are saying about what appetizer to eat. So I think all of us are somewhat touched by actionable data, right? However it's sourced, sensors or otherwise. So, as people are thinking about how to implement edge and IoT or actual data at the edge, what are your recommendations on how agencies could accelerate this adoption? So we talked about a little bit like incremental implementation. Where should they start? What are your recommendations? So Vishwas, I don't know if you want to tackle that.
Yep, I would say that where should they start? I think having a reference architecture, I think, is important. And I'm not talking about the technical, which languages to use, but at a high level, figuring out what are the important use cases and how are these use cases going to be realized, right? At a very high level, when we look at a reference architecture, sort of a building block level, we really have three pieces, right? We have talked a lot about IoT and the edge layer. And then we have to talk about the platform layer, which is ingesting the data, analyzing the data. And then the third layer in that is sort of the enterprise layer, if you will, because now that you've collected the data, you've analyzed the data, you need to have a workflow to make use of that data in your business processes. So having a canonical reference architectures that everybody can coalesce around is the first thing. Second thing would be, of course, how are you going to secure, what kind of devices? And the third thing would be, improving and understanding. And this is not to be taken lightly. The amount of data that you're collecting is just enormous. So improving your ability for data wrangling, data quality, and then improving the understanding of simple things like, what machine learning kinds of techniques and what data analytics kinds of techniques can you use will be one step. And I always like to say, and I think Jim said this earlier as well, is start small, get something working quickly, even if it is a few set of sensors, see if it is adding value, establish the reference architecture, and then repeat that process to continue to improve this entire architecture or ecosystem, if you will.
Vishwas, it's very interesting. You mentioned data, I think, in almost every other sentence. So is this owned by the chief data officer, or who really carries out that strategy you talked about in a organization or agency in government?
So from my perspective, the data issues, who owns this data, there has to be a data steward. If it's the chief data officer, if an organization is advanced enough to have a chief data officer, of course, they own what data is being collected, what is the retention period, what kind of data, what analyzing. That's a chief data officer function. but then there are other functions as well that have to collaborate in order to make sense of this data and bring it to bear essentially. Is that, am I answering your question?
Yes.
Yeah, okay.
I mean, often we're saying data is the new oil, and that this is the real asset for the enterprise. And so
Yes.
there's a little bit of a mindset shift, and we're even seeing in government, that the chief data officer is a new position that's evolving because of this kind of pressure of so much data being generated, whether at the edge or within the enterprise, et cetera. Jim, do you have any thoughts on kind of recommendations what agencies can do to accelerate adoption?
Yeah, I mentioned it earlier, and I think Vishwas really highlighted having that architecture and the three pieces. I would just really go back to saying, hey, start small, start with something that has a good value, but is not something that is so urgent or something where it can't fail because it's such a cultural issue. And if you have some minor failures, it could be perceived in an organization that it just doesn't work. And then that might set you back a little bit more than it should be. So I would always kind of say logistics and maintenance are two key things that have a lot of data. They need a lot of help, and they currently have good systems to improve upon. Yeah, and I'll pause there, see if there's any other questions.
No, I think I'm not sure if I shared this question with you, but as you're talking, I'm thinking about what's next in Edge and IoT, right? We see a lot of innovation around precision agriculture, around manufacturing, health, any kind of role where you're in the field. So what kind of innovation are you thinking could be the next thing when we're talking IoT and Edge?
Yeah, and I think Vishwas, kind of summed a lot of that up in his answer about the role of the CTO. And in my mind, we're starting this journey to take a single stream of data and put it through some analytics to drive a source. And I think the next steps that I think you'll see over the next year to 2 years is really combining multiple streams of data and getting a lot more granular on like a multi-domain analysis. And there's been a lot of research reports written in the government or in the military about a multi-domain battle and combining different layers, because it's not necessarily only one element of military operations. They get combined, and when you start combining them, it gets very complex, and you're going to need some heavy computing power, both in the hyperscale cloud and then also at the edge.
Vishwas, any thoughts on that?
Yes. So Karina, you asked what is next, and there's one specific piece of IoT which is of great interest to me, and I saw some recent announcements related to something called the digital twin, and many of the listeners today are probably familiar with that. But if they're not, I'll just give you a very quick definition and then go back and talk about why I'm excited about this. So digital twin is a very important pattern in IoT, where you are representing a physical asset. You're essentially modeling it in a digital or a virtual manner. So why would you want to do that? Because let's say you go to an army base, you may have sensors there, but these sensors may be old. How do you create, using these sensors, how do you create a digital representation of these array of sensors so that you can get a unified view of the base, right? These may be old sensors, they may have different commands that they support. So how do you do that? And the notion of digital twin, of course, is that you're representing these sensors using a virtual model essentially. So recently, the Azure IoT team announced something called the Azure Digital Twin Definition Language. So you can essentially take your sensors, you can model them out, you can say, these are my sensors, and these are the kinds of operations they support, essentially in a JSON file. And once you have done that, you can have a representation of this. So you might have a sensor, a security sensor across different hallways, maybe, and now transform those sensors into some sort of a map that tells you how these sensors are located and what they're doing and what actions you can perform on these. So that's a big step forward, I think. That was a recent announcement. I think that will help a lot of organizations, or in this case, agencies who have had disparate types of sensors try to do a lot more with modeling this information. So that's one thing I wanted to throw in there as I see an important step forward.
Yeah, there was a question that just came in from the audience about driverless cars. And when will they interact with highway signs and other objects around them? Any thoughts on that? Because it seems, the comment was, it seems like the effort is on the car itself and the infrastructure side. That's right. Being neglected. Any comments on that?
Yeah, specifically, and Jim, I don't know if you wanted to comment on that. I'll be very brief and then yield the floor back to you. But if you look at I'm reading the comment here as well. These cars can, you're absolutely right. They're all of these cars, the driverless cars, have some sort of a chip which is, monitoring the road and in real time analyzing the pictures, right? And the compute capability that is available in these cars really is determining how good a decision you are making. So previous generation of driverless cars maybe only sensed that there's a car ahead of them, and if the car ahead of them stopped, they would stop. But now that we have more computing capability and maybe even GPU chips in the cars, you can take a real-time picture of a traffic light and then make some decisions based on that. And in some ways, I think this question is very interesting, right? If everybody has to take a picture of a traffic light, whether it is red or green, make a real-time analysis of what it is, and then make a decision, well, you are using the compute capability of the car, but wouldn't it be nice if I had this connected ecosystem where the traffic light was sending these messages to me in some other manner that was far more reliable? I think that may be the question as well, that once we get to an interconnected systems, these things will be much easier than sort of the brute force approach of everybody analyzing the picture.
Yeah, how do you input things like Waze and other kind of applications adding to that data? Jim, any thoughts on that as we close our conversation?
No, I think Vishwas summed it up pretty well.
Yeah, no, I think it was a great question as we think about what's next. This was a great panel discussion. I want to thank both of you for contributing to our meetup tonight. So if we don't have any other questions from the team, again, I want to thank everybody. Our next meetup is on July 22nd. Please be sure to join us then. We're in the middle of developing that agenda, so any thoughts on that would be great. And be sure to check out our YouTube channel where we host all our meetup content, and then again join us for all our meetups coming up. Vishwas, I don't know if you had any closing remarks.
Karina, if I may, I don't know if you remember this or not, Karina, but you were talking about our meetup started almost 4 years back. Yeah. And I remember this very well because the very first instance of the meetup we had 4 years ago, that January evening, which was really cold and in DC, we had few people, of course, we were just getting started. So we had few people, and there was a demo which was related to IoT, and I somehow forgot about that, but probably worth repeating, and I think will make Jim happy here. the demo was about, it was an IoT demo, if you remember, Karina. It was about a study that had been conducted by National Institutes of Health, where you are monitoring the heart rate variability of a soldier out there in the field, and then using that information, and this was based on the analysis that was conducted in previous wars, using that variability to detect an early onset of PTSD. And it was a fancy demo with Event Hub and Stream Analytics and things like that. So I just reminded of that. So here we are 4 years later with so much more capabilities in the platform. So I just was remembering that. And
becoming very real, yes. And I wonder what we'll be talking about 4 years from now. But, and I think, again, a big thank you for all the speakers who contributed to this evening and for all who attended tonight. We really appreciate that and look forward to more. So with that, we'll sign off, and good night, and thanks to all.
Thank you, Karina.
Bye-bye.